Yes. Good morning, my children. Today we are continue our discussion on last year KEAM paper. Our today's target, Unit 4. Unit 4 mean thermodynamics, kinetic theory of gases, oscillations and waves. അപ്പോൾ അത്രയും ചാപ്റ്റർ നമ്മൾ നാലാമത്തെ യൂണിറ്റായിട്ട് നമ്മൾ ഇൻക്ലൂഡ് ചെയ്ത് അതിൽ നിന്നുള്ള ചോദ്യങ്ങളാണ്. എന്തൊക്കെയാണ് സാധാരണഗതിയിൽ വേണ്ട എന്നുള്ളത് നിങ്ങൾക്കറിയാം, പറഞ്ഞിട്ടുള്ളതാണ് പലവട്ടം. ഗോ ത്രൂ ദി ക്വസ്റ്റ്യൻ ഫസ്റ്റ്, സീ വാട്ട് ഈസ് ഗിവൺ, വാട്ട് ഈസ് ആസ്ക്ഡ്, ദെൻ ഹൗ വി ക്യാൻ കണക്ട് വിത്ത് ദ ഇൻഗ്രീഡിയൻറ്റ് ഗിവൺ. നമുക്ക് തന്നിട്ടുള്ളത് വെച്ചിട്ട് ചോദിച്ചതിലേക്ക് അങ്ങനെ എത്താം. അതിനെ മെയിനായിട്ട് വേണ്ടി വരിക കുറേ ഫോർമുലകളുടെ സപ്പോർട്ടാണ്, അപ്പോൾ അതറിയണം. പിന്നെയുള്ള ചിലപ്പോൾ എങ്കിലും എന്തെങ്കിലും ഒരു ഫിസിക്കൽ ലോജിക്ക് അപ്ലൈ ചെയ്യേണ്ടി വരാം. ആ ഫിസിക്കൽ ലോജിക്കിൻ്റെ ഡെപ്ത് അനുസരിച്ച് ഡിഫിക്കൽറ്റി കൂടും, ഇത്രേ ഉള്ളൂ. അപ്പോൾ ഉറപ്പായിട്ടും ഫോർമുലകളൊക്കെ അറിഞ്ഞിരിക്കണം എന്ന് ആലോചിക്കുക, പഠിക്കുക നന്നായിട്ട്. നൗ കം ടു വി ക്യാൻ സ്റ്റാർട്ട് വിത്ത് അവർ ടുഡേ ടാസ്ക്. അവർ വെരി ഫസ്റ്റ് ക്വസ്റ്റ്യൻ. An ideal gas is insulated vessel. An ideal gas in an insulated vessel is allowed to expand into a similar evacuated vessel. That means the second vessel is fully empty. Perfect vacuum is there through a valve. Then what happens? Now in the second vessel, since it is fully evacuated, when we open the valve, then that expansion is known by another name called free expansion. So our gas is allowed to expand, is going to undertake what is called free expansion. In free expansion, work done is zero, because in the second vessel pressure is zero, because evacuated, and that is called free expansion. And free expansion, work done is zero. When our expansion takes place in the vacuum region, that expansion is called free expansion. In free expansion, work done is zero. Therefore, the answer, work done is zero. External work done on the gas, the pressure of the gas is doubled, the volume of the gas is doubled, pressure of the gas remains the same, temperature of the gas increases. No work done. External work done on the gas, that is wrong. Pressure of the gas is doubled. No. Volume gas is doubled. That is true. Reason, the gas expands to identical vessel, the volume doubles. No work done. And therefore the option is volume of the gas doubles. Important thing is that this is what is called free expansion, in which work done is zero. We can go to our next question. In a Carnot engine, the temperature of zinc is 350 and the efficiency of the engine is 50%. Then temperature of the source. In Carnot engine, strictly speaking, in our NCERT syllabus it is removed, but you start in the class. Efficiency is given by, in terms of output work done by input heat energy, W by Q, is equal to, in terms of temperature for an ideal Carnot engine, chemical as T1 minus T2 by T1. For T1 and T2, T1 is the temperature of the source from which heat is absorbed. T2 is the temperature of the sink to which the heat is rejected. And both must be in absolute scale, not in degree centigrade. Now come to our question. In our question it is said that sink temperature T2 is 350, efficiency is 50%, then temperature is T1 is asked. So efficiency is equal to 50%, mean 1 by 2 is equal to T1, temperature of the source, that is what is asked. T2 350 Kelvin, it is given in Kelvin, therefore Kelvin. Sometimes it may be, in most cases they will give that in degree centigrade. അപ്പോൾ നമ്മൾ എന്ത് ചെയ്യണം? We have to convert that into Kelvin. That അതാണ് കാര്യം. Now T1 is equal to 2T1 minus 700. Now you can say that taken to that T1 is equal to 700. 700 Kelvin, so option is equal to A. We shall go to our next question. The ratio of the respective RMS velocity of the gas molecule. Ideal gas at 327 and 627 degrees centigrade. You know RMS speed is given by root of 3 RT by M. RMS velocity, RMS speed is given by root of 3 RT by M. M is the molar mass, T is the temperature in Kelvin, absolute scale. From this we can say RMS, proportional root to T. Now we are given two temperatures and find the ratio of the velocity. Therefore, V1 by V2 directly proportional is equal to root of 327 plus 273, 600 by other one is equal to 900. So root 2 by 3. Sorry. Root of this one is equal to 2 by 3 equal to root of 2 by 3. So the value is equal to root 2 is to root 3. Root 2 is to root 3, the option is equal to C. Next question. The total energy of a gas mixture of 1 mole of oxygen and 3 moles of argon at a temperature T given by neglecting vibration mode. What is total energy? You know, for 1 mole per degree, energy is for molecule per degree half kT, Adiabatic theorem. Mole per degree half kT, RT. And mu is the number of moles and n is the degree of freedom. Per mole per degree energy is this much. For n degree energy is equal to n into. For mu moles, mu into. So this is the energy equation. Where mu is the number of moles, n is the degree of freedom and half RT. So this is the energy. Now in our problem, what is given? We are given a mixture of 1 mole of oxygen. What is the energy of 1 mole of oxygen? 1 mole, 1 into oxygen, diatomic. It is diatic and therefore you know the degree of freedom is equal to 5. 5 to RT. This is the energy of 1 mole of oxygen. Now 3 moles of argon. Then plus energy of argon, energy of the number of moles, 3 into degree of freedom, argon, monatomic, 3 by 2. Now add up these two. We get the total energy. This on addition, we can get that is equal to 7 RT. It's equal to 5 by 2 RT. This is equal to 4 power 2.5. This is equal to 4.5. And therefore is equal to 7 RT. Simply add up the energy of each component. You got the answer. There we know energy per molecule per degree half kT. Per mole half RT. N degree of freedom into N. Number of moles mu into B. That's it. Next question. A man fly a bullet at a 2 hillock, one shorter and the other is taller. The taller one is behind the smaller one. The first echo is heard after 6 seconds and second echo after 12 seconds. Then the distance between the hillock. Velocity is gone. Now, what is the situation? This is the person. And here there is a mountain or a hillock. And here there is the next one which is much taller. The first echo means the sound wave produced by him and returns. Then by echo principle, this distance is d1. d1 ആണെങ്കിൽ, if this distance is d1, d1 is the time interval between the production of sound and the reception of reflected sound echo. d1 ആണെങ്കിൽ, then you know that total distance d1 plus d1. 2d1 is equal to v into t1. t1 is the time interval between. From this d1 is equal to v t1 by 2. d1 and t1 is given to you. The first echo heard from the nearby. First echo heard is 6 seconds. 6 seconds, and therefore is equal to v into 6 by 2 is equal to 3v. d1. Similarly, d2. This is d2. The sound wave went there and returned. Same equation. Same equation, we can say that d2 is equal to v into t2 by 2. d2. And that is equal to v into echo. The time interval between the production and the reception of echo, 12 seconds. Therefore, 12 by 2. So, 6. Now, our question is, what is the separation between these two? D. D is equal to d2 minus d1. Therefore, d is equal to d2 minus d1. It's equal to 6v minus 3v. 3v. 3 into velocity of sound is given 330. So 990. So option is square box. Next question. So one application question we can say. നേരവും പറഞ്ഞിട്ട് ഒരു application question ആയിട്ട് വേണം ഇപ്പോൾ ഇത് പറയാം. ഇപ്പോൾ നമ്മൾ ചെയ്തു പോയി. ഇപ്പോൾ particle execute simple harmonic motion. If a particle executes simple harmonic motion with the time period t and displacement x is equal to a cos omega t, you know the displacement function is cos mean, cos omega t. It's very evident that you start the observation when the body is at the extremum. Whereas if you are given x is equal to a sin omega t, you start the observation when the body at the mean position. So it is a cos function. Therefore, this is the total path length and this is the mean position. You start the observation when the body at this location, because x is equal to a cos omega t. Then the acceleration of velocity of the particle at t by 2, where t is the time period. After t by 2 time, we have to locate the particle. You know, here the particle start and here reaches t by 4, then reaches here t by 4 one more, therefore t by 2. So after time t by 2, the particle is here at the other extreme. Other extremum velocity is 0. So here are 0 and here also the other extremum. Total time is t by 2, the other extremum, and therefore velocity is equal to 0. Acceleration is maximum, and acceleration is equal to, acceleration is given by omega square a, where is the amplitude of the oscillation. So that is our answer. V is equal to 0 and a is equal to omega square a. One more thing, since sin is there, then this is positive x and this is minus, and therefore the acceleration, displacement is here. Displacement is measured from here to here. Acceleration is measured from here to here. Therefore minus omega square. Therefore our answer is equal to 0 minus omega square a. But that answer is not there. Here 0 is there, velocity is there. Here a omega square is there, but minus is not there. Therefore the question was deleted. The question was deleted due to this reason. No answer. Correct answer is equal to 0 minus omega square. Shall go to our next question. All real gases behave like ideal gas. Real gas is not an ideal gas, but you may remember the PV against PV by T against P graph. You can say that at a certain situation, a real gas may extend the ideal nature to some extent. And what is that condition? Low pressure and high temperature. Low pressure and high temperature. Low pressure and high temperature, so the option. Directly the option is C. Next question. 0.5 mole of nitrogen at 27 degrees centigrade is mixed with 0.5 mole of oxygen at 42 degrees centigrade. Then the temperature of the mixture. This problem is, strictly speaking, repetition. ഇന്ന് നമ്മൾ ആദ്യം ചെയ്ത ടോട്ടൽ എനർജി കാൽക്കുലേറ്റ് ചെയ്തു. അതിൻ്റെ ഒരു റിപ്പീറ്റേഷൻ പോലെ തന്നെയാണ് ഈ പ്രോബ്ലം. Here we have got number of moles is given, nitrogen N2, diatomic, and therefore you can calculate the energy of that component of the mixture. Similarly, energy of the next component after mixing result in temperature. That is what is. So total energy before mixing and after mixing is to be same. That we are going to do. Now what is the energy of the first component? Nitrogen. And one more thing you can say, the problem made easier. Both are diatomic. And therefore, but the energy of the first mixture 0.5, number of moles 0.5. That is the mu into number of moles into degree of freedom into half RT. This is energy per degree per mole. Number of degree, number of moles. For nitrogen, half into number of moles. Degree of freedom, nitrogen, diatom, 5 into half R. Temperature is given 27 degree, 27 with 300. This is the energy of hydrogen. And it is mixed with 0.5 mole of oxygen. Then what is the energy of oxygen? Number of moles, half. Into oxygen is also diatomic. 5 into half R into temperature of the oxygen. 42 degree. 42 mean 273 plus 315. 315, that is the energy of. Now this is the total energy of the mixture. Now temperature of the mixture is as. Now mixing, since both are that and one is half mole and other is half mole, their total number of moles is equal to 1. Therefore total energy of mixing is equal to total energy after mixing. Number of moles is equal to 1. Degree of freedom, diatomic mixture is also diatomic 5 into half RT. That is the temperature of the mixture. Now solve and find the value of T. Here we can see that half 5 by 2R cancel out. Then what remains? 300 by 2 plus 315 by 2 is equal to, okay, 300 by 2 plus 315 by 2 is equal to the resulting temperature. Now, doing that, we will obtain 307.5. Therefore, T is equal to 307.5. But answer is not in Kelvin. It is in degree centigrade, and therefore you minus 273. 5, 4, 3, 34.5. 34.5 degree. That is the resulting temperature of the mixture. So option is equal to box. Next. a wave with a frequency. Now a wave with a frequency 600 Hz and wavelength 0.5 travel a distance 200 meters in air in a time. First of all, we are given the frequency and wavelength. At once you can calculate the velocity of the wave. The velocity of the wave is equal to L where n is the frequency, that is given as 600. The lambda is equal to 0.5 meter, half. So 300 meters per second. Now what is the question? What is the time taken to travel a certain distance in air medium? Velocity is obtained, distance is given, time is given by distance by velocity. Distance to be traveled is 200 meters. By velocity 300, you calculate it. 2 by 3 seconds. 0.67. So the answer is box. Next question. If the fundamental frequency of a stretched string of length 1 meter under a given tension is 3 Hz, then fundamental frequency of stretched string of length 0.7 under same tension. You know the fundamental frequency expression for a stretched string, n is equal to 1 by 2L into root of T by M. Here, tension is the same, material is the same, that means these two are same. And therefore you can say n into L is a constant. Since D and M are constant, n into L is a constant. In first case, what is the frequency we going to you? 3 Hz, length is equal to 1. So 3 into 1 is equal to. Second case, since we are not changing M and T, we are changing the length. What is the length in second case? 0.75. And what is the frequency? So n dash into 0.75. Therefore, n dash is equal to 3 by 0.75. Is equal to 4. 3 by 4 is equal to 4. So 4 Hz. So answer is equal to. Stretched string fundamental frequency formula 1 by 2 L root of T by M. Next question. Thrissur law. Question is, the zeroth law of thermodynamics leads to the concept of temperature. Heat flow only if there is a temperature difference. Zeroth law give you that idea, and therefore they give you the idea about not heat but the temperature. Body flow, body or heat energy flow from a body at a higher temperature to lower temperature, not the one which possesses more higher heat energy to the one lower heat energy. It is not the concept. It will flow from higher temperature to lower temperature till temperatures are the same. Yes. Therefore, the option is C. Go to our next question. If M adiabatic, Mi isothermal or the slope of adiabatic and isothermal curve of an ideal gas, then how they are related? Basic idea that is the slope of adiabatic gamma times slope of isothermal, and that is what is slope of adiabatic Ma gamma times pressure specificity, the slope of isothermal M. Therefore, the option is equal to Ma is equal to gamma M. Option is equal. Next. the work done. The work done by a gas on a system is 0. No work is done. Work done basic formula W is equal to integral dW is equal to integral PdV. So there must be change in volume. If there is no change in volume, work done is 0. No change in volume in isochoric. Therefore, in isochoric process, work done is 0. Isochoric process. So option is C. Next one. Cp, Cv, and M are specific opacity of constant pressure, specific opacity at constant volume, and number of degree of freedom of the polyatomic gas system, then Cp by Cv. Now, here the question is deleted because of the fact that where here F is, they have told you that it is the number of degrees of freedom. But if F is the number of modes of vibration for polyatomic, the modes of vibration, instead of this, it is modes of vibration, and each mode corresponds to 2 degrees. Therefore, total number of degree becomes 2F due to vibration. But here, by mistake, F is a number of degree of freedom, and therefore answer is not there. But if it is total mode, then that very well there, the answer is there, 4 plus F by 3 plus F. That is gamma. Of a polyatomic gas having F modes of vibration, the answer is equal to this much. But the answer is not there because of the fact they gave you F is the number of degree. But if F is the number of modes, the answer is there. And therefore the question is deleted. Next question. When number of molecules. When number of molecules per unit volume of an ideal gas 0.8 into 10 raised to 24, the mean free path for its molecule for its molecule 2.2 into 10 raised to minus 5. The number of molecules per unit volume is equal to 1 into 10 raised to 24, the mean free path. So we have to write down the formula for the mean free path. Mean free path formula lambda is given by 1 by root 2 n d squared. Now the expression is called 1 by root 2 n d squared. Here the dependence, you have to write down the dependence of mean free path and number of free path and number of molecule per unit volume. Per unit volume, that therefore dependence is lambda proportional to 1 by n. Lambda proportional to 1 by n. And question is, first data, the number of molecule per unit volume and mean free path is given. Therefore, you can say that mean free path 2.2 into 10 raised to minus 15. 10 raised to minus 5. Proportional to 1 by number of molecule per unit volume 0.8 into 10 raised to 24. In second case, the mean free path I don't know, lambda dash proportional to 1 by number of molecule per unit volume 1 into 10 raised to 24. Equation number 1, this is equation number 2. Then 2 by 1 gives you lambda dash by 2.2 into 10 raised to minus 5 is equal to lambda dash is equal to 0.8 into 10 raised to 24 by 1 into 10 raised to 24. Cancel out. So lambda dash is equal to 0.8 into 2.2 into 10 raised to minus 5. So the answer goes to box. Then multiplication, the answer is 1.76 into 10 raised to minus 5. Simply multiplying these two, get the answer. Next question. Next question is a particle execute. A particle executes linear simple harmonic motion with an amplitude A and the angular velocity omega. The ratio between its acceleration amplitude means maximum acceleration, and displacement amplitude is displacement amplitude. Displacement amplitude is amplitude. What is the relation between them? You know, acceleration at any instant, acceleration is gone by omega square x minus 1 in quanta. Modulus is enough. So acceleration maximum is equal to omega square into displacement maximum. Let's see. Question is this ratio. Acceleration maximum by capital A is equal to omega square. Omega square option is there in box. Speed of. Now, speed of a transverse wave, structured string under tension T, and linear density mu. Simple formula is this. Velocity of a transverse wave along a structured string is given by root of T by mu. T by m or T by mu, where mu or m is the linear mass density. T by mu. So option is there box. Next question. Monoatomic. So one question is missing here. Now next question is a monoatomic ideal gas. A monoatomic ideal gas n moles heated from temperature T1 to T2 under two different conditions. One at a constant pressure, second at a constant volume. The change in internal energy of the gas. Now, the same gas is heated under two situations. At a constant volume, P constant. At a constant pressure, P constant. Through the same range. Here that delta T, here delta T is the same range. Then the amount of heat energy required for increase in temperature mean increase in internal energy, the same for both. The amount of energy used for increase in internal energy in these two situations are the same, but gas is the same and the change in temperature is the same. But here you have to give more heat at a constant because work is done. So for doing work, more energy is given. But the part used for increase in internal energy, the same in these two situations. So same in both the process. Heat given is not the same, but heat energy used for increase in internal energy is the same in both cases. Next question. The ratio between the root mean square velocity of oxygen and ozone molecule O2, but other one is O3. Molecules at the same temperature, at a given temperature. You know the RMS is given by Vrms is given by Vrms is given by root of 3RT. In first case, we have to find V1 for oxygen, therefore proportion, or we can say VRMS. VRMS proportion 1 by root of molar mass. So VO2 proportional to 1 by O2, 2O, 2 into O. O means they are the molecular mass of one oxygen molecule. Velocity of O3 proportional 1 by root of 3O and dividing VO2 by VO3 equal to root of 3 by 2. Root of 3 by 2 is equal to 3 is to root 3 is to root 2. And option is equal to sorry, option is equal to the answer is equal to root 3 is to root 2. Next one. Particle executing. A particle executing linear simple harmonic motion with amplitude A. If the total energy of the oscillation is E, which is constant throughout, then its kinetic energy at a distance 0.707 A from the mean position. Now, this is the path line and this is the mean position and this is plus A. 0.707 A mean A by root 2. 0.707 A mean A by root 2. And this is A by 2, this is A by root 2. What is the question? Question is, the energy, total energy is equal to E, then energy at a distant point, so energy of the particle at A by root 2. When amplitude is the RMS value, amplitude is this RMS value, displacement is the RMS value of the amplitude, that means here A by root 2 or 0.707 A. What is the kinetic energy? Then it's kinetic energy at the question. Total energy is C. You know, here the kinetic energy potential energy ratio, Ke by Pe ratio, A by root 2 is equal to 1. But it is A by 2, Ke by Pe ratio is equal to 3. And this is the location and where you know Ke by Pe ratio is equal to 1. Therefore, total energy is equally divided. And therefore, the kinetic energy half of the total energy E by 2. But the potential energy there half of the total energy E by 2. Because the position is that. Next one. The equation of a stationary wave is 1. We are given an equation. It's a stationary wave equation. Standard formula is sin kx into cos omega t. Instead, you are given an equation like this, y is equal to. The question is the distance between the consecutive nodes. Consecutive node means lambda by 2. Distance between any two neighboring nodes, lambda by 2. In a neighboring antinode, lambda by 2. Node and antinode, lambda by 4. For stationary wave, we know. Our question is we have to find lambda by 2. Now, our standard equation for a stationary wave is equal to A 2A sin kx into cos omega t. Comparing the coefficient of x is k. Our coefficient of x is here is equal to k, and therefore k is equal to coefficient of x is equal to pi by 2. But what is k? 2 pi by lambda. So 2 pi by lambda is equal to pi by 2. Pi cancel out. Therefore lambda is equal to 4. Question is not lambda, the distance between two neighboring nodes. This is lambda by 2. Lambda you got 4, therefore our answer is equal to 4 by 2, that is equal to 8. Answer is box. Next question. Efficiency of Carnot engine. Question is, efficiency of a Carnot engine operating between steam point and ice point. Repetition. Efficiency is given by T1 minus T2 by T1. T1 minus T2 by T1. Here the 2 points, instead of giving the temperature, they are given the names. The temperature. Temperature name on a steam point is 100 degrees centigrade, mean 373 Kelvin. Minus ice point 0 degrees centigrade 273 by T1 373 is equal to 100 by 373. It is 27%. This one calculation 27%. Next question. The process depicted by the following PV diagram. But figure is not there. I shall go you. Question is this. The process depicted by the following PV diagram for two systems, X and Y. You are given a figure like this. Is PV and one is like this. And which is isobaric, isochoric, adiabatic. In the Chodhyam. Options is the isothermal and isobaric. X and Y. Second option is isothermal and isothermal and adiabatic. But we cannot distinguish whether it is isothermal or adiabatic. Reason. In the problem it is given that PV diagram two systems. But if it is the same system, one isothermal and adiabatic, then we can say the one which has got larger slope is adiabatic and lesser slope is isothermal. In that way, you can look into the slope and say. But here it is not possible because it is for two different systems and therefore you cannot distinguish or we can differentiate which process isothermal or this process adiabatic or isothermal cannot be done and therefore the question was deleted. Reason it is for two different systems. നമുക്ക് ആൻസർ ചെയ്യാൻ പറ്റില്ല. ഒരു സിസ്റ്റമാണ് എന്ന് പറഞ്ഞിരുന്നെങ്കിൽ പിന്നെ സ്ലോപ്പ് നോക്കി നമുക്ക് പറയാമായിരുന്നു. ഇത് പറയാൻ പറ്റാത്തതിന് കാരണം അത് കാരണം കൊണ്ടാണ് ക്വസ്റ്റ്യൻ ഡിലീറ്റഡ് ആണ്. Next question. Two similar metallic rods. അപ്പോൾ പ്രീവിയസ് യൂണിറ്റിൽ the question ആണ്. അപ്പോൾ same length L and area cross section A are joined and maintain a temperature T1 and T2, T1 greater than T2 at one of their ends and shows as shown in figure. If their thermal conductivities are K and K by 2 respectively, the temperature at the joining point at a steady state, definitely. At a steady state, what is the temperature at this point? Where the temperature is T, here. Then since at a steady state, you get the heat conducted through one. That means this part, heat conducted per second and heat conducted per second through this part are the same at a steady state. Heat flow or steady state, heat conducted through this part is same as heat conducted through this part. And what is the formula for heat conducted? Ka. Now we can say Ka. T1 minus T2. Here I temperature type higher and there will be lower. T1 minus T. Length L. Heat conducted to this part is equal to K by 2 into area is the same. Temperature is this higher temperature and this is lower temperature. Equal to T minus T2 by L. L is the same. From this Ka, L cancel out. And what remains is multiplied 2T1 minus 2 capital T is equal to T minus T2. take this other side. 3t is equal to 2t1 plus t2. Therefore, the resultant temperature at the interface is called 2t1 plus t2 by 3. 2t1 plus t2 by 3. Option C. നമുക്കറിയാം ഇത് പ്രീവിയസ് യൂണിറ്റിൽ ഒരു ചോദ്യമായിരിക്കണം ഉറപ്പായിട്ട് നമ്മൾ ഗ്രൂപ്പ് തിരിച്ചപ്പോൾ. Now, shall go to our next question. According to equipartition principle, energy contributed by each translational degree of freedom and rotational degree of freedom at temperature T are respectively, whether it is translation or rotation or vibration, each degree of freedom contribute an energy half kT. In equipartition theorem says so. Whether it is translation degree or rotation or due to mode, each mode corresponds to degree of freedom. So each degree contribute half kT. Here, whether it is translation or rotation, each degree contribute half kT. Even vibration, each degree contribute half kT. But vibration is a mode. Each mode contribute 2.5 kT, that is equal kT. Each mode of vibration. But here our answer is half kT, half kT. So the answer is equal by equipartition theorem. Kinetic energy. The kinetic energy of 3 moles of diatomic gas molecule in a container at a temperature T is same as that of kinetic energy of n moles of monatomic gas in another container at the same temperature, the value of n. മൂന്നാമത്തെ ചോദ്യം നമ്മൾ ചെയ്യാൻ വേണ്ടിയിട്ടായി. So we have to calculate the energy of first one and equate the energy with the second one. But the first one, 3 moles of diatomic energy equation, number of moles, diatomic degree of freedom, in energy per mole per degree, half RT. This is the energy of 3 moles of diatomic gas. Is same as the kinetic energy of n moles of monatomic. Same as equal to n moles of monatomic, degree of freedom 3, per mole per degree half RT. It is given they are the same. Now find the value of n. Half RT, 3 cancel out, therefore n is equal to 5. Number of moles is equal to 5. So option is equal to down. Next question. A string of length L is fixed at both ends and vibrate in fundamental mode. String is vibrating in fundamental mode. The speed of wave in the string is v. Then the angular wave number or the static wave. Angular wave number is us. Wave number is 1 by lambda. Angular wave number is equal to k, propagation constant, 2 pi by lambda. Wave number is 1 by lambda. Angular wave number is 2 pi by lambda. It's also known by propagation constant k. So this is what is us, 2 pi by lambda. Now that is the angular wave number. Now to find out that what is the data, a string of length L fixed at both the end vibrate in fundamental mode, mean like this. So fundamental mode vibration mean like this. This is length L and node to node distance is lambda by 2. So lambda by 2 is equal to L. Therefore lambda is equal to 2L. Then what is the propagation constant? That is our angular wave number. Angular wave number k is equal to 2 pi by lambda equal to pi by L. It's equal to pi by L. Option is down. Next. The ratio between the frequencies of the third harmonic in the closed organ pipe and open organ pipe of same length is. The ratio between the frequency of the third harmonic of a closed organ pipe. Closed organ pipe length L. So closed one. What is the fundamental frequency? P by 4L. And what is the permitted overtone? Ratio we know that 1 is to 3 is to 5 is to 7 is to etc. And therefore, what is us? Ratio between the frequency of the third harmonic. Third harmonic means first overtone frequency for a closed pipe. 3. First overtone frequency is the third harmonic. So 3 into P by 4L. Lambda by 4. Lambda is equal to 4. Now an open pipe. Same length. Now what is the permitted frequency in the case of an open pipe? 1 is to 2 is to 3 is to 4 is to 7. All integer multiplied. 1 is to 2 is to 3. Then what is the third harmonic? Third harmonic 3. Into fundamental frequency V by 2L. This is the third harmonic frequency of open pipe. This is the third harmonic frequency of closed pipe. And what is us? Ratio between the frequency of third harmonic in closed. Therefore, we have to find third harmonic 3 V by 4L by 3 V by 2L. 3 V will cancel out, L will cancel out, and 2 by 4. So our answer is equal to 1 by 2. 1 is to 2. So option is equal. Option is box. Next question. A tuning fork vibrating at 300 Hz initially in air is then placed in a trough of water. The ratio of the wavelength of the sound wave produced in air to that in water, given that velocity of sound in water is and air are of 1500 meter per second and 350 meter per second. Now we know the velocity expression V is equal to nu lambda or L lambda, nu lambda. In this, frequency nu is the inherent property of the source, not that of medium. Medium nothing to do with the frequency. Frequency is fully the property of the source. Whereas velocity is fully the property of the medium. And correspondingly lambda is also property of the medium. ഇവിടെ നിങ്ങൾ ഈ ഇക്വേഷൻ നോക്കുകയാണെങ്കിൽ അല്ലെ ഒരാൾ സോഴ്സിൻ്റെ പ്രോപ്പർട്ടിയാണ് നിങ്ങൾ എവിടെ വെച്ചാൽ ഏത് മീഡിയത്തിൽ വെച്ചാലും അത് മാറില്ല, അതാരാ ഫ്രീക്വൻസി. നേരെ മറിച്ച് ബാക്കി രണ്ടാളും വെലോസിറ്റി ആൻഡ് ലാംഡ. വെലോസിറ്റി ഫുള്ളി ഡിസൈഡഡ് ബൈ ദ മീഡിയം. മീഡിയമാണ് തീരുമാനിക്കുക. അപ്പോൾ മീഡിയത്തിൽ വെലോസിറ്റി മാറണമെങ്കിൽ പിന്നെ ആ മീഡിയത്തിൽ വേവ് ലെങ്ത് സോ അഡ്ജസ്റ്റഡ്. So that these two are decided by medium, whereas this is decided by the source. ഇതാണ് അതിൻ്റെ കൺസെപ്റ്റ് ഉള്ളൂ. ഇനി ഇവിടെ നമ്മളോട് എന്ത് പറഞ്ഞു ഈ പ്രോബ്ലത്തിലെ tuning fork vibrating 300 Hz is same whether it is vibrating in water or in air. Frequency remains the same. And velocity in air is given, water is given. Velocity of sound in water is 1500. So in water, velocity in water 1500. Therefore we can write 1500 is equal to frequency nu into lambda in what? What may be the frequency? That remains the same. Whereas velocity in air given to you 350 meter per second. Then again, velocity in water 350 is equal to frequency nu into lambda in air. Dividing equation number 1 is equation number 2. This order letters. The ratio of the wavelength of sound wave produced in air. Lambda A by lambda W. Equation number 2 by equation number 1. Yes. But frequency is the same. Lambda A by lambda W is equal to 350 by 1500. 7:30. So 7:30. So the option is equal to. Now the point that you have to remember, I told you, frequency is the inherent property of the source, whereas velocity decided not by the source but by medium, and accordingly wavelength also. Next question. What is the question there? The pressure of ideal gas. The pressure of an ideal gas is proportional to cube of its temperature on absolute scale. In another process they told is adiabatic. Then the value of Cp by Cv. The data per problem is given that pressure P proportional to cube of absolute temperature Tq. And it is said that it is a adiabatic process. So for adiabatic process, a standard expression connecting pressure and temperature, T raised to gamma by P raised to gamma minus 1 is a constant, or P raised to gamma minus 1 proportional to T raised to gamma. Now we are connecting that in this format. Therefore, P proportional to T raised to gamma by gamma minus 1. So this is the standard equation known to you, in which a P proportional to T raised to gamma by gamma minus 1. You are given that P proportional to TQ. So it is comparing. Here the power of T is gamma by gamma minus 1. Therefore comparing gamma by gamma minus 1. Comparing with this equation equal to 3. Gamma is equal to 3 gamma minus 3. Therefore 2 gamma is equal to 3. Gamma is equal to 3 by 2. Gamma is equal to 3 by 2. Option dog. Next question. The gas at which something missing is there. The gas at which, something missing is there. A question must be read like this. The average kinetic energy per molecule. ഇവിടെ ആഡ് ചെയ്യാനുണ്ട് കുറച്ച് സാധനങ്ങൾ ഇവിടെ ആഡ് ചെയ്യണം. Question incomplete ആണ്. Question is read like this. The average kinetic energy per molecule of an ideal gas at 27 degree is E. The temperature of then fill it here. Then go to bottom. The question read like this: the average kinetic energy per molecule of an ideal gas at 27 degrees centigrade is E. The temperature of the gas at which average kinetic energy per molecule will be 2E. So you have to read the question like this. Average kinetic energy per molecule of an ideal gas at 27 degree. Average kinetic energy per molecule is a measure of absolute temperature. That's the data. At 27 degree, it is E. Then the temperature of the same gas at which average kinetic energy doubles 2E at what temperature. You know the answer. You have to arrange the question accordingly. And what is the principle? Average kinetic energy per molecule proportional to its absolute temperature. Kinetic energy proportional to absolute temperature. Here the average kinetic energy doubles. Temperature doubles. Therefore, the temperature become, our answer is equal to T. Average kinetic energy doubles, temperature doubles. What is the temperature initially? 27 degree. 27 degree mean initial temperature is 27,300 Kelvin. 27 degree. 27 degree mean 300 Kelvin. Then energy doubles to E when absolute temperature doubles 600 Kelvin. So our answer is 600 Kelvin. 600 Kelvin answer is in degree centigrade minus 273. Minus 273 if you do 7, 2, 3. 327. 327. Basic principle, kinetic energy of an ideal gas directly proportional to its absolute temperature. Next one. X is equal to 2 cos pi t plus sin pi t, the amplitude of the oscillation. Now you get there are two SHMs, two phases are there in the expression for X. It's equal to 2 cos pi t plus 2 sin pi t. You can visualize this. Then the question is, what is the resultant amplitude? Now the two phases, resultant amplitude is equal to root of. Resultant amplitude is equal to root of S square plus B square. Resultant amplitude is root of S square plus B square. Is equal to 2 square plus 2 square. Is equal to 2 square 2 will come 2 root 2. 2 root 2. So option is D. Now these are two phases mutually perpendicular, and the resultant is given by root of S square plus amplitude of the first one square plus amplitude of second square root. Because these two are phases mutually perpendicular. Now next question. The velocity of a traveling wave given by equation 10 raised to minus 2 sine 200t minus x by 5 meter is given by. We are given a traveling wave equation. and compare with this one is equal to A sin omega t minus kx, a progressive, traveling or a progressive equation. And what is asked there? Velocity. Velocity in the case of a progressive wave is given by coefficient of time by coefficient of x. That is equal to omega by k. Omega is equal to pi n. K is equal to 2 pi by lambda. 2 pi will cancel with n lambda. That is the velocity. That is the equation. Therefore, we can say n lambda, nu lambda is the velocity. And therefore, you can say, instead, looking into the expression, you can remember the velocity of a traveling wave is given by coefficient of time by coefficient of x. Coefficient of time here is 200. So substituting, comparing and substituting 200 by coefficient of x is equal to 1 by 5 is equal to 1000 meter per second. Proper unit. The option is equal to 1000. Now, that finishes our target, unit 4. And we will meet tomorrow again with the unit 6. And now we completed the first year, all the questions from first year. Tomorrow we start with the next unit 5, 6, 7 and 8, 4 units. And they are all from second year topics. So see you tomorrow. Thank you. വീണ്ടും പറയാനുള്ള ഫോർമുലകളൊക്കെ പഠിക്കണം എന്നുള്ള കാര്യങ്ങളൊക്കെ ഓർക്കുക കേട്ടോ. ഫോർമുലകളും അതുപോലെ പറ്റാവുന്ന അത്രയും ക്വസ്റ്റ്യൻസ് ചെയ്യാൻ ശ്രമിക്കുക. Yes, see you tomorrow. Thank you.